Welcome to this video lecture series on antenna and wave propagation. In this video, we'll discuss pattern multiplication. So why pattern multiplication? Till now, we have discussed the radiation pattern of 2-point antenna elements only. So when we need to find out the radiation pattern of more than 2 antenna elements, we need to have some concept. So this concept is pattern multiplication. In this video, we'll discuss the pattern multiplication of 4 element antenna array and 8 element antenna array separated by lambda by 2 distance and having 0 phase between them. So first we are considering 4-point antenna array. So now we have 4 antennas, antenna 1, 2, 3 and 4, which are in phase and are separated by lambda by 2 distance. So the distance between all of them is equal, and which is lambda by 2, and all are in phase. So when we need to find out the output radiation pattern of this structure, I will see the radiation pattern of antenna 1 and 2 separately and antenna 3 and 4 separately. So now I'll focus on antenna 1 and 2. So I have studied that the radiation pattern of 2 antennas which are separated by lambda by 2 distance and having 0 phase between them is like this. So the radiation pattern of antenna 1 and 2 is like number 8. So it is represented like this. Similarly, antenna 3 and antenna 4 are also separated by lambda by 2 distance apart and having 0 phase between them. So the radiation pattern of antenna 3 and antenna 4 also looks like the figure 8. So now the final radiation of antenna 1 and antenna 2 lies exactly at the center of antenna 1 and antenna 2. So as you can see that the radiation lies at lambda by 4 distance from antenna 1 and lambda by 4 distance from antenna 2. So now we are terming it as antenna A. So antenna A is an imaginary antenna which has radiation pattern which looks like the figure 8. Similarly, we are considering the output radiation of antenna 3 and 4 lies at exactly the center of antenna 3 and 4, which is lambda by 4 distance from antenna 3 and lambda by 4 distance from antenna 4. So the total distance between antenna A and antenna B, which is the output of antenna 3 and antenna 4. So the total distance in between A and B is lambda by 4 plus lambda by 2 plus lambda by 4. So antenna A and antenna B are lambda distance apart because lambda by 4 plus lambda by 2 plus lambda by 4 is equal to lambda. So now we are considering the group patterns. So when I need to find out the group pattern, I will see the radiation pattern of antenna A and antenna B. So now antenna A and antenna B are lambda distance apart and we know that there is no phase difference between them. We can verify it from the radiation pattern of antenna A and antenna B. So the output radiation pattern of antenna A and antenna B would look like this. We have studied that the output radiation pattern of two system of antenna which are lambda distance apart and having no phase between them is represented like this. So now we have group pattern and now we have individual pattern. So now we'll do pattern multiplication and we'll find out output radiation pattern of 4-point antenna structure. So the individual pattern is having two nulls. As you can see from here, the nulls is in plus x and minus x direction, and similarly the group pattern is having 4 nulls. So the property of pattern multiplication is that the output radiation pattern would have the nulls which is the summation of the nulls of individual pattern and group pattern. So we have the total nulls as the sum of the nulls of individual pattern and the sum of the nulls of group pattern, which is 2 plus 4. So the output radiation pattern will have 6 nulls. So now we have represented 6 nulls like this. Now we will do the pattern multiplication. So now we will multiply the unit pattern with the group pattern to find out the final radiation pattern. Now we know that in the direction of nulls there is no radiation. So when this pattern is multiplied by this pattern, we never get any radiation in the direction of nulls. So we can see that in the direction of plus and minus x there is no maxima, and in the direction of plus and minus y there would be always maxima, as maxima and maxima are multiplied by maxima and maxima in this direction. But in plus x and minus x direction, the maxima are multiplied by null, so which is represented by a null only. So this is how we can do pattern multiplication throughout 360 degree. We can find out the multiplication of group pattern with the unit pattern with the help of this concept, and then we'll find out the final radiation pattern. Now we'll find out the final radiation pattern of 8-point antenna array, which are lambda by 2 distance apart and having 0 phase between them. So now I am clubbing first 4 antennas and the last 4 antennas together. So antenna 1, 2, 3, 4 are represented as group A, and antenna 5, 6, 7, 8 is represented as group B. So now we need to find out individual pattern and group pattern again in this case. So for individual pattern, I found out the radiation pattern of group A in my previous 4 antenna array radiation pattern. So I'll take that as my individual pattern, which has 6 nulls. So now I'll see the group pattern. So now group A and group B are 2 lambda distance apart. We can see this from this structure that the distance between group A and group B is 2 lambda, and we know that there is no phase difference between group A and group B. So when we need to find out the final radiation pattern of group A and group B, we'll see the radiation pattern of 2 antennas which are 2 lambda distance apart and having 0 phase between them. So which I derived in one of my previous video. So you can see that the final radiation pattern is looking like this, which is having 8 nulls. So again applying the property of pattern multiplication on this, so the total nulls in the output radiation pattern would be 8 plus 6, which is equal to 14. So when I made 14 nulls in this structure, it looks like this. Now I need to do the pattern multiplication of individual pattern and group pattern. So I'll multiply the radiation components at various points of the individual pattern with the group pattern, same like before. So at nulls I know there would be 0 radiation. So I saw when I multiplied various radiation pattern, so in plus and minus y direction there would be maxima. So as you can see that there is maxima in plus y direction and minus y direction. So this is how I compute the radiation pattern of group of antennas using pattern multiplication concept. I hope you like this video. Like this video, subscribe my channel and stay tuned for the further videos.